Hi students, so today we are going to start with the topic that's a fifth lesson here, continuity and differentiability. Okay, so this is what you are going to start with today here. And now here if you see with to study differentiability, this continuity part is very important here. So your first exercise will be related to continuity, and from the second exercise in this lesson you will be starting with differentiability here. Okay, so we need to know what is meant by a continuous function first and what are the conditions for continuity. With that we will be doing few questions under the first exercise. Okay, so you all know what is meant by a continuous function. So when do you say that a function is said to be continuous, or when do you say that there is a continuity in the topic? So when do I say that there is a continuity in the topic I speak? For example, the previous class whatever I have taken and this class whatever I am going to take, if there is a link between both, okay, so if it connects, or from where I left I am going to start here, that only we call, then only I can say that there is a continuity in the topic. The same concept only you have here. So what I have done here is I have taken a curve. Okay, so here we have the x-axis and the y-axis in this case. So here we have taken a curve y is equal to f of x. So here y is equal to f of x. Now here if you see, maybe I can draw the curve here. You have the curve y is equal to f of x in this case. So y is equal to f of x means if you see here this curve, there is a continuity in this case, that is the curve is said to be continuous here. So here suppose I have a point A, then in that case in the y axis what will I get here? It will be nothing but f of A. Okay, so here if you see I can write it as f of a here actually. So what do I say here? In this case a function is said to be continuous in its domain if its graph is a curve without breaks or jumps throughout its domain. That is what I told here. No, you see, if you see here there is no jump, no break or anything like that actually here in this curve. That only we call it as a continuous function here. Okay, so here if you see this graph, it doesn't have a break. So for an example for a function which is not continuous, how can I take here? Suppose I have a function like this. Okay, so here I have a function like a step. So here if you say there is no continuity between these curves here. So what do I say here in this case? Actually here this is not a continuous function. That is what we mean by saying it's not a continuous function. Got it? So here for the problem's sake I cannot be taking each curve, plot the graph and then check whether it is said to be continuous or not. So how do I check? Okay, theoretically or mathematically, how do you check that the function is said to be continuous or not here? So for that what you will be doing here is we'll have to find out the left hand limit and the right hand limit in this case. So what do you mean by the left hand limit and the right hand limit actually here? When in this case if you see here, when your limit of x tending to a, okay, it converges from the left hand side, okay, we call it as the left hand limit. So how do you generally denote it? As limit of x tending to a minus. Similarly if it converges from the right hand side, what will I write here? Limit of x tending to a plus. This only we call it as a plus is nothing but your right hand limit. So we'll see the definition here. Continuity at a point. So here if you see I have drawn a number line here, this point A. Okay, so here if you see if x tending to a minus and x tending to a plus. So what is your x tending to a minus? It's nothing but your x less than a. What is x tending to a plus? That's nothing but x greater than a. So if these both converge to one point, then I can say that what is it actually? It is said to be continuous. So here if you see if it converges to one point, you know there is no break. For example, I take a real line here and I say that your x tending to a minus, it converges at the point B, and your x tending to a plus, it converges at the point C here. So what happens actually here? It is still here and till here. So there is a break in the curve till here, okay, in this part. And that is the reason we say that, okay, it is said to be converging from the left hand side as well as to the right hand side, the left hand limit and the right hand limit. This is what I have defined here. A function f of x is said to be continuous at a point x is equal to a of its domain if and only if your limit of x tending to a, f of x is equal to f of a. In other words, we write it like this. Limit of x tending to a minus, I told you this is nothing but your left hand limit. In short, I will write it as LHL here. and that is equal to limit of x tending to a plus. So here this one we call it as the right hand limit, that is equal to f of a. This is what you have here. Now the note, what is it I'll have to prove in this case actually here? Your limit of x tending to a minus limit of x tending to a plus. So how do you evaluate it actually here? This is how you write here. Your right hand limit means I can write your limit of x tending to a plus your f of x, or you write it as f of a plus 0, or we replace it by a plus h in this case. Okay, in other words, it's nothing but it moves towards the right hand side by a very negligible quantity. That negligible quantity is nothing but 0. Okay, so here it is 0. So replace your x by a plus h and take the limit as h tending to 0. When I do the problem, it will be more clear to you here actually here. So here in this case, your x, if you see here, it tends to a plus h in this case, as your h tends to 0, I say here. That is, your h in this case, it tends to a very negligible and approximate value in this case. So here replace x by a plus h and take the limit as h tending to 0. Got it? Next is your left hand limit here. So what's your left hand limit here? It's limit of x tending to a minus f of x. So in that case, it will be nothing but a minus 0. But here, this is the rule you have here. Replace your x by a minus h. Okay, so towards the left hand side, it's nothing but a minus h and take the limit as h tending to 0. Why do I take the limit as h tending to 0? Because it will move towards the left hand side with a very negligible value. That's why I write it as h tending to 0 in this case. Okay, so this is the rule we generally apply here. Now with this in mind, we'll start with the first exercise here, exercise 5.1. Prove that the function f of x is equal to f 5x minus 3 is said to be continuous at x is equal to 3 at x is equal to minus 3 and at x is equal to 5. Okay, so always when a problem you have it like this, first check if it's an algebraic function. Yeah, it is an algebraic function. Next step, what you will do here is just substitute these values and see if you have a defined value here. So what is it? At x is equal to 0, what will you get? Your limit of x tending to 0, f of x is equal to limit of x tending to 0. It means that your x is replaced by 0 here. F into 0 minus 3, which is equal to 0 minus 3, that is equal to minus 3. It's just a simple one mark question you can have here. That's all. Okay, whether the function is said to be continuous or what is limit of x tending to 0, f of x equal to. That's all. Got it? Now here the next one. At x is equal to minus 3 also they have asked us to check. So at x is equal to minus 3, if you will have to check, what will you write? Limit of x tending to minus 3, your f of x is equal to limit of x tending to minus 3, f 5x minus 3. This is what you get here. So if it's 5x minus 3, how do I write? 5 into minus 3 minus 3. So what is 5 into minus 3 here? It's minus 15 minus 3, which is equal to minus 18. Got it? Now the next one, at x is equal to 5. So what is x is equal to 5? What will you get? Limit of x tending to 5, f of x is equal to limit of x tending to 5, 5x minus 3. This is what you have here. Now you just substitute the value of x here. So you will get 5 into 5 minus 3. So it is 25 minus 3, which is equal to 22. This is what you have in this case. You understood how we proceed with such problems here? Okay, it's a very simple one. The first one, just check whether it is said to be continuous or not. So everywhere you get defined values here at whatever points you have. Therefore, what is the conclusion I can write here? F of x is said to be continuous at what point actually here? X is equal to 0, x is equal to minus 3 and x is equal to 5. This is what you have here. Got it? Yes. Now the third question here. Okay, so what is the third one here? Examine the following functions for continuity. So here examine the following functions for continuity. Earlier problem, that is the first problem, what was it? They asked us to check whether it is said to be continuous at those points they asked us to check. But here if you see, they have just given a function. Okay, the first subdivision, if you see, f of x is equal to x minus 5 is just given to us, and we'll have to check whether it is said to be continuous or not. A very simple one if the points are not given here. So what is your f of x equal to x minus 5? it's nothing but a polynomial. Okay, so I'll just draw an approximate graph here. X is here, okay, f of x is equal to x minus 5 means you know that y equal to x minus 5. This is what you get. Now you take any values for x, either 0 or 1, any value in the real line system. Okay, generally it will be in the real line system or a real number. So you take any value. For example, if I take x is equal to 1, what will you get? 1 minus 5 is what? Minus 4. So here you will get, what is it here? Y is equal to minus 4. So you have it as y equal to minus 4. So when x is equal to 1, what is your y equal to here? Minus 4. So you will get 1 comma minus 4. This is how you get. Now the next one. X is equal to 0. What will you get? Y is equal to minus 5. So what is 0 comma minus 5? Where will I have here? 0 comma minus 5. This is how you get 0 comma minus 5. Next, similarly put minus 2. When you put minus 2, what will you get? Minus 2 minus 5 is what? Minus 7. So you may put minus 2 comma minus 7. So like that, if you take any values in the real number, you have definite values and the curve will not get a break in between. You understood? So that's the reason I have written here f of x equal to x minus 5 is a polynomial function. Okay, since it's a polynomial, it is said to be continuous for all values of x. So here if you see, it is continuous for all values of x in this case. So this is one advantage you have for a polynomial. So if it's asked for 1 mark, check whether the concerned polynomial is said to be a function, it's continuous or not. You can just check here any values you can take in the real line here and then substitute it. If you see here, the curve will not have a break. You may think, why I have not taken decimals here? You can also take decimals in this case, plot it, and then you will get for sure values you will be having here, and then you can say that it is said to be continuous for all x. Got it? So B subdivision, f of x is equal to 1 by x minus 5. Okay, the second question, B subdivision. Again, I'll have to check whether the function is said to be continuous or not here. So what did I tell you actually here? Randomly you can take any values of x I told you here. So when you take x is equal to 0, what will you get here? So here when you take x is equal to 0 in this case. So what is your x is equal to 0 will give me what here? It will be 1 by 1 minus 5. So 1 by 1 minus 5 you will have a value in this case 0 comma 1 by minus 1 by 5, you can have it. Similarly, when you take 1, also you can have 1 comma 1 by minus 4. Now when you take 5, what will happen? You will have it as 1 by 0. Is your 1 by 0 defined? It's not defined, because what is 1 by 0 equal to here? 1 by 0 is nothing but equal to infinity. So here in this case, what can I say here? F of x is continuous for all values of x except at x is equal to 5. Okay, except at x is equal to 5, I will say that the function is said to be continuous. That is, except at x is equal to 5, the function is said to be well defined at all the other places. You understood? That is the meaning of saying that it is continuous for all values of x except at x is equal to 5. Got it? Okay. Similarly, the C subdivision, we will see what is the rational function given to us. F of x is equal to x squared minus 25 divided by x plus 5. So here if you see, you can simplify it actually here. This by using a squared minus b squared, you have written it as x minus 5 into x plus 5 divided by x plus 5. So your x plus 5 and x plus 5 gets cancelled. You are left with x minus 5. So here again, your x minus 5. What is your x minus 5 here actually? Your x minus 5 is nothing but a polynomial. So what about this polynomial here? It is said to be continuous for all values of x in this case. Okay, so here if you see, it's continuous for all values of x. Got it? Yes. Now here your D. Okay, D is what? F of x is equal to absolute value of x minus 5, or we call it as modulus of x minus 5. So before going on to this problem, you need to know the definition for modulus of x. What is your modulus of x? F of x is equal to mod x, which is equal to x when x is said to be greater than or equal to 0, and it is equal to minus x when x is said to be less than 0. So how do you write here? Your f of x is equal to plus x minus 5 when x minus 5 is greater than or equal to 0. The same definition I have applied here. So x minus 5 comma x minus 5 greater than or equal to 0. Similarly, the next one is what? Minus x. So how do I write minus x as? minus of x minus 5 when your x minus 5 is said to be less than 0. So see the condition I have written here, greater than or equal to 0, and here it is less than 0. Got it? So don't write both as less than or equal to here. Got it? Now you can write it as x minus 5 comma, what will you have here? X is said to be greater than or equal to 5 and it is equal to 5 minus x when you have x is said to be less than 5. This is what you get here. So here if you see in this case, now only comes your left hand limit and the right hand limit in this case. So here your left hand limit and the right hand limit is what? There is a break at this point here. Okay, this is the point actually here, the function you have. For x greater than or equal to 5, you have it as x minus 5 and 5 minus x you have here. Got it? So here what I have done here is, we'll just draw a real line in this case. When I draw a real line here, I have it as x here. In this case it's minus 5. Here if you see, we write it as plus 5. This is what you have here. Okay. Now we'll come to the first step here. The right hand limit. What is your right hand limit here? Limit of x tending to 5 plus. So what do you mean by saying limit of x tending to 5 plus actually here? X tending to 5 plus itself, it's nothing but x greater than 5. It means that x greater than 5. So for x greater than 5, what is your f of x child here? It's nothing but x minus 5. So limit of x tending to 5 plus, you can write it as x minus 5. You can write it is equal to your x tending to 5. Here in this case, you can just substitute it. What will you get? 5 minus 5 which is equal to 0. This is what you have here. Okay, 5 minus 5 which is equal to 0 you get. Got it? Now your left hand limit. Similarly, we'll find the left hand limit. What is your left hand limit here? X tending to 5 minus. So what is your x tending to 5 minus? It means that your x is less than 5. Okay, x is said to be less than 5, which is equal to limit of x tending to 5 minus. So what is limit of x tending to 5 minus? It's nothing but 5 minus x. So here if you say it as 5 minus x which is equal to 5 minus 5 which is equal to 0. Now if you check your left hand limit and your right hand limit, both have got the same values here. So what can I write here? Your limit of x tending to 5 plus f of x is equal to limit of x tending to 5 minus f of x, that is equal to 0. Therefore, what can I say here? Your function f of x is continuous at x is equal to 5. This is what you have here. So the only concept which you will have to understand here is this. Okay, clearly once again I am telling you here, if x tending to a plus, it means that your x is greater than 0. Okay, here I have not put x is equal to a plus h. From the next problem onwards, we will be doing that. Next is what? X tending to a minus. So what is your x tending to a minus? That's nothing but x less than a, and here you will have x is equal to a minus h. You understood? The sixth question here, find all points of discontinuity of f where f is said to be defined by f of x is equal to 2x plus 3 if x is said to be less than or equal to 2 and 2x minus 3 if x is greater than 2. So at what point you will have to check the discontinuity here? At x is equal to 2. Okay. So here in this case at x is equal to 2, you will have to see from the left hand side and the right hand side whether the limit converges or not. In other words, I will have to find out what is limit of x tending to 2 minus f of x is equal to limit of x tending to 2 minus, what is your 2 minus f of x is what? X less than 2. So here if you see, it's nothing but x less than 2. So for x less than 2, what is your f of x equal to here? It's nothing but 2x plus 3. So if it's like that, what will you do? Put x is equal to 2 minus h when h tends to 0. Okay, so here this is a general rule you have here. Now when you substitute it, what will you get? Limit of h tending to 0, 2 into 2 minus h plus 3 which is equal to limit of h tending to 0, 4 minus 2h plus 3 you get. So here this is equal to limit of h tending to 0, 4 plus 3 is what? 7 minus 2h which is equal to 7 minus 0, that's nothing but equal to 7. Got it? Similarly, we'll go over to the right hand limit. So what is your right hand limit here? Right hand limit is nothing but limit of x tending to 2 plus f of x is equal to limit of x tending to 2 plus. So what is your limit of x tending to 2 plus denote here? It's nothing but x greater than 2. So for x greater than 2, what is your f of x equal to here? It is 2x minus 3. Okay. So we'll just substitute here 2x minus 3 you get. Now here it is x greater than 2 means what will I put? Put x is equal to 2 plus h when your h tends to 0. This is the general rule you will have to remember. I told you for x tending to a plus you denote it as x is equal to a plus h I told you there the same way. So limit of h tending to 0, 2 into your x will be replaced by 2 plus h, 2 into 2 plus h plus 3 which is equal to 2 limit of h tending to 0. It's 4 plus 2h minus 3. Okay, so here this is what you get here, 4 plus 2h minus 3. So what is 4 minus 3? What will you get here? It's nothing but 1 plus 2h you will get. So when I substitute your limit here, it becomes 0. So it's 1 plus 0 which is equal to 1. So are they equal now? So here you have 1 and here if you see you have got 7. So both are not equal in this case. So if they are not equal, so what do I say here? The function is said to be discontinuous at x is equal to 2. Now if you read the question itself, you will know. Find all the points of discontinuity only was asked. So it is discontinuous at what point actually here? At x is equal to 2. Okay, a very simple concept here. Just see where the point breaks. Find out x tending to that minus and the other one extending to plus here, and check whether they both are equal, and you will have to say whether it is said to be continuous or not. Okay. 7th question. F of x is equal to modulus of x plus 3 if x is said to be less than or equal to minus 3 and it is equal to minus 2x if minus 3 less than x less than 3, 6x plus 2 if x is said to be greater than or equal to 3 here. Okay, so now when you see this function itself, okay, first thing you will have to check. Okay, we'll have to check at what points all I'll have to check. You'll have to see what are the breaking points you have here. Minus 3. What's the next point you have here? 3. So you'll have to check at 2 points in this case. So what is it? We have to check the continuity at x is equal to minus 3 and at x is equal to plus 3. This is what you'll have to check here. Got it? So before that, there is one more problem I have here. What is the problem you have actually in this case? Your modulus of x you get here. Modulus of x, if you see here, first thing you know, what is a definition for modulus of x? I told you for the previous problem itself. F of x is equal to mod x when it is equal to minus x when x is less than 0 and it is equal to plus x when x is said to be greater than or equal to 0. But here in this question, if you see, it's clearly given as x less than or equal to minus 3. That is mentioned to us clearly. So if it is x less than minus 3, what is your f of x equal to? Minus x. So how can I write my modulus of x as? I can write it as minus x here. So that problem is over. You understood? So if it is modulus, please be careful when you write the function. First, finish writing the function whether it is equal to plus x or minus x or both. In that case the interval also will change. So write it correctly and then go with the continuity part here. So since x is said to be less than 0, in other words you are said to be less than or equal to minus 3, I have it as minus x plus 3. If x is said to be less than or equal to minus 3, it is equal to minus 2x if minus 3 less than x less than 3, and it is equal to 6x plus 2 if x is said to be greater than or equal to 3. Now, to check the continuity at x is equal to minus 3. Okay. So, to check the continuity at x is equal to minus 3, first thing you will have to see whether the left hand limit is equal to the right hand limit. This is what I will have to check here. Now, we will take the left hand limit here. So, what's the left hand limit? Left hand limit is equal to limit of x tending to. So, I told you it's at the point x is equal to minus 3. So, it is x tending to minus 3 minus, don't confuse this minus and minus, this is actually, this denotes your left hand limit, okay, minus 3 minus f of x. So minus 3 minus means, it means that your x is less than minus 3, got it, less than or equal to, that's not a problem here, okay. So don't confuse only the inequality whether less than or greater than, just check that alone. For x less than minus 3, what is your f of x here? Minus x plus 3. So that's what I have substituted it here. Limit of x tending to minus 3 minus x plus 3, you have it. Got it? Now put x is equal to, what is the working rule I told you here? A minus h. What is your a here? Minus 3. So minus 3 minus h when h tends to 0. This is what you get here. Okay, when h tends to 0. Now I can write left hand limit is equal to limit of h tending to 0 minus x you have here. So it's minus of, okay, so what will you get? Minus 3 minus h plus 3. This is what you get here. So minus 3 minus h. Now it is equal to limit of h tending to 0, minus of minus, it becomes plus. Here again it becomes plus. So it is 3 plus h plus 3, which is equal to limit of h tending to 0, 6 plus h. Now you can substitute the limit. So what's the answer you get here? It is equal to 6. So you understood? You've got your left hand limit here. Now at x is equal to minus 3, you will have to find out the right hand limit also. Don't forget that. Okay, if you want, you can just take the side heading as at x is equal to minus 3. That's the first one you're going to see here. Got it? Now right hand limit is what? Limit of x tending to minus 3 plus f of x is equal to limit of x tending to minus 3 plus, okay, so here in that case it is x greater than minus 3. So what is your x greater than minus 3 here? X greater than minus 3 is what actually here? See here, minus 3 and the 3. It means that your greater than minus 3, what is your f of x here? It's nothing but equal to 2x. So how do I write in this case actually here? You write it as equal to minus 2x. You understood? Okay. Now if it's a right hand limit, what did I tell you? It will be replaced by minus 3 plus h when your h tends to 0. Correct? So your right hand limit is equal to limit of h tending to 0 minus 2, replace it here. So when you replace it, what will you get? Minus 2 into minus 3 plus h. Minus into minus is what? 6. And here when you multiply, it's minus 2h you will get. So here substitute it. What will you get here? 6 minus 0, that is equal to 6. Now are they equal here? Your 6 is equal to 6 in this case. So what can I say here? Right hand limit is equal to the left hand limit. Therefore it is continuous at x is equal to minus 3. That's the thing. Okay, so we have finished one part. Limit of x tending to minus 3 minus f of x is equal to limit of x tending to minus 3 plus f of x. Therefore f of x is continuous at x is equal to minus 3. So I told you there are 2 points here. What's the other point actually here? The other point is nothing but at x is equal to 3. Okay, so the next point is x is equal to 3. So we'll do for x is equal to 3 next. Okay. Next is to check the continuity at x is equal to 3. So to check the continuity at x is equal to 3, as you know, we have the left hand limit as well as the right hand limit here. So first we'll start with the left hand limit here. So what is your left hand limit? If you want, I'll just write the function. The first one alone I'm not writing here. It is equal to minus 2x when minus 3 less than x less than 3. Got it? And it is equal to 6x plus 2 when x is said to be greater than 3. Okay, the inequality may be less than or equal to, I would have forgotten there. Just this is a function, that's all I need here. So limit of x tending to 3 minus f of x. So 3 minus f of x means 3 minus. So towards the left hand side or for x less than 3. So for x less than 3, what is your function here? F of x is equal to minus 2x you get here. So what is your x equal to? X is equal to 3 minus h when h tends to 0. This is what you get here. X is equal to 3 minus h when h tends to 0. Now we'll just replace it. It is equal to limit of h tending to 0 minus 2 into 3 minus h you get here, which is equal to minus 6 plus 2h you will get. So it is equal to minus 6 plus 0, which is equal to minus 6. This is what you get here. Now your right hand limit. What is your right hand limit here? Limit of x tending to 3 plus, that is towards the right hand side of 3. So towards the right hand side of 3, what will you get? F of x, which is equal to limit of x tending to 3 plus 6x plus 2. Why do I write it as 3 plus 6x plus 2? That's nothing but x greater than 3. So for x greater than 3, what is your f of x equal to here? It's nothing but equal to 6x plus 2. This is what you get here. So it is equal to 6x plus 2. So what is your x equal to here? X is equal to 3 plus h when your h tends to 0. It's equal to 3 plus h when h tends to 0. So what is your right hand limit equal to here? Right hand limit is nothing but limit of h tending to 0. Your x will be replaced by 3 plus h. So you will have it as 6 into 3 plus h plus 2. Okay, so here limit of h tending to 0, it's 18 plus 6h plus 2, which is equal to limit of h tending to 0 you get here. So it's 20 plus 6h. Now when I substitute it, what will you get? It is equal to 20. Now are they equal here? No. Okay, it is not equal. So what will I write in this case actually here? Limit of x tending to 3 minus f of x is not equal to limit of x tending to 3 plus f of x. Therefore, what can you say here? Your f of x is discontinuous at x is equal to 3. But f of x is said to be continuous at what point actually here? At x is equal to minus 3. You understood? As I told you earlier, just know this basic. The other one is very important, very easy for you. Okay. The next one, 8th question. I'll have to check. Okay. Check the discontinuity at what point or the continuity, whatever it is. F of x is equal to mod x by x if x is not equal to 0 and it's equal to 0 if x is equal to 0. It's another important question here. Okay. So here you have it as modulus of x you have here. So as I told you already, when you have this modulus, when you check the continuity, you will have to be a little careful because you all know modulus of x is equal to plus x when x is said to be greater than or equal to 0 and it's equal to minus x when x is said to be less than 0. Now, what is the point I'll have to check for continuity or discontinuity at x is equal to 0? This is what I'll have to check here. Got it? Now, we'll start with the left hand limit here. So when I start with the left hand limit, you know here, what will I write? It's equal to limit of x tending to 0 minus f of x. You know here, if it is 0 minus, what is it actually here? It is nothing but for x less than 0, you know here. So if it is x less than 0, how do I write here? It's nothing but your modulus of x divided by x. This is what you have here because it's clearly mentioned for x not equal to 0. For x not equal to 0, it means that for x less than 0 as well as for x greater than 0, it's going to be the same thing there. Only at the point x is equal to 0, you will have it as equal to 0. So now here we'll check. So here you have it as mod x divided by x here. So you can write x is equal to 0 minus h when your h tends to 0. This is what you have here. So here this is equal to 0 minus h. So here if you see for x less than 0, what will I get here in this case? Your limit of h tending to 0, what will I have? It's nothing but minus x divided by x. If you want, you can finish it here itself. So minus x divided by x is what? It is equal to minus 1. You understood here because it's x tending to 0 minus. It's nothing but your x less than 0. So you have it as limit of x tending to 0 minus x by x, that's equal to minus 1. Otherwise, drew by the traditional rule here, x is equal to 0 minus h when h tends to 0. So you have it as limit of h tending to 0. You have it as modulus of 0 minus h divided by 0 minus h, which is equal to mod minus h divided by minus h. What is modulus of minus h? That's nothing but h itself because absolute value of any negative value is also equal to positive. So h by h is equal to minus 1. Got it? Similarly, your right hand limit. What's your right hand limit here? Limit of x tending to 0 plus f of x is equal to limit of x tending to 0 plus modulus of x divided by x. So you all know that it's nothing but x greater than 0. So for x greater than 0, what can you say? Your modulus of x is what? Just x divided by x, that is equal to 1. So you can do it by this method also. In that case, it will stop till here. Otherwise, go by this traditional one here. X is equal to 0 plus h when h tends to 0. So your right hand limit is equal to limit of h tending to 0 modulus of 0 plus h divided by 0 plus h, which is equal to mod h by h. So you will get h by h is equal to 1. Are they equal here? You have got minus 1 here and you have got plus 1. So what will I write here? It is not equal, and therefore we say that f of x is said to be discontinuous at x is equal to 0. This is what you have here. Got it? It is said to be discontinuous at x is equal to 0. Got it? Yes. Now the next question here, the 11th one. What's the 11th one? F of x is equal to x squared minus 3 if x is said to be less than or equal to 2, and it is equal to x squared plus 1 if x is said to be greater than 2. Okay. Now you will have to check the continuity for this function. The question, it goes like this. So to check the continuity, at what point I'll have to check here? Yeah, at x is equal to 2. This is the point I'll have to check. So we check the continuity at x is equal to 2. So when I check the continuity at x is equal to 2, of course I'll have to find out the left hand limit as well as the right hand limit here. So what will you get? Limit of x tending to 2 minus f of x is equal to limit of x tending to 2 minus. So for x less than 2, what is your f of x equal to here? It is equal to x cube minus 3. Okay, you can just check the book there. So in that case, here you know your x is equal to, what will I get here? 2 minus h when your h tends to 0. By now you are used to it. That's why I have not written this step here. X is equal to 2 minus h when h tends to 0. So how do I write here? Limit of h tending to 0. Your x is replaced by 2 minus h the whole cube minus 3. So a minus b the whole cube formula. So it is a cube minus 3a squared b plus 3ab squared minus b cube. So it's 8 minus 12h plus 6h squared minus h cube. You already have a minus 3 here, so it's equal to minus 3. So limit of h tending to 0, 8 minus 3 is what? 5 minus 12h plus 6h squared minus h cube. So for limit of h tending to 0, substitute the value of h as 0, here also as 0 and here also as 0. So what's the answer you get? It is equal to 5. Got it? So this is your left hand limit. Next we'll go for the right hand limit here. So what is your right hand limit? It is equal to limit of x tending to 2 plus f of x. So for x greater than 2. So for x greater than 2, what is your f of x equal to here? It is x squared plus 1. Okay, so x tending to 2 plus. So in that case, your x is replaced by 2 plus h when your h tends to 0. This is what you get here. X is equal to 2 plus h when h tends to 0 you have here. So how do I write here? Limit of h tending to 0, your x is replaced by 2 plus h the whole square plus 1. So here this is equal to limit of h tending to 0, a plus b the whole squared. What is a plus b the whole squared? 4 plus 4h plus h squared plus 1 you will get here. So how do I write in this case? It is equal to limit of h tending to 0, 5 plus 4h plus h squared. Now when I substitute the limit, this becomes 0, this also becomes 0. So you are left with limit of h tending to 0, 5 plus 0 plus 0, that's nothing but equal to 5 you get. Now are they equal? Your limit of x tending to 2 minus f of x is equal to, because both are equal to 5. Here also you have got it to be equal to 5. Now if I check this, here also you have got it to be equal to 5. Therefore, what can you say? Your f of x is said to be continuous at x is equal to 2. Okay. The 12th one, f of x is equal to x power 10 minus 1 if x is said to be less than or equal to 1, and it is equal to x squared if x is said to be greater than 1. These all questions are of the same category, children. Here you will have to check whether it is said to be continuous or not, or you will have to check for discontinuity. Okay, so the question is said to be the same. That's why I have written the function alone here. F of x is equal to x power 10 minus 1 if x is said to be less than or equal to 1, and it is equal to x squared if x is said to be greater than 1 you get here. Now again I have written the question here. So you all know at what point I will have to check here? At x is equal to 1. This is a point I will have to check here at x is equal to 1. So at x is equal to 1, as usual, your left hand limit and your what is it here? Right hand limit here. So for the left hand limit, what will you get? Limit of x tending to 1 minus f of x is equal to limit of x tending to 1 minus x power 10 minus 1. This is what you get here. Okay, it's x power 10 minus 1 you have. So what is your x equal to here? 1 minus h as h tends to 0. Okay, s is equal to 1 minus h as h tends to 0. Now what's your LHL equal to? Limit of h tending to 0. So your x is replaced by 1 minus h the whole power 10 minus 1. This is what you have here. Now what's the next step? Replace your h by 0. So when I replace it, what will you get? 1 minus 0 the whole power 10 minus 1, which is equal to 0 you have here. Okay, so what will you get? You will have it as 1 minus 1, that's nothing but equal to 0. That is how you get it to be equal to 0. Understood, children? Here. Now the next one here. So what's the next one you get? Put x is equal to 1 plus h as h tends to 0. So x is equal to 1 plus h. Why? Because it's a right hand limit. I have written it in the second step here. Limit of x tending to 1 plus f of x is equal to limit of h tending to 0. Okay, so here what is your f of x for x greater than 1 here? For x greater than 1, your f of x is nothing but equal to x squared. So when you replace your x by, what is it here? 1 plus h, what will happen? It will be 1 plus h the whole squared you will have here, which is equal to 1 plus 0 the whole squared, which is equal to 1. This is what you have here. So here if you see you've got 0, here if you see you've got 1. Are they equal? No, they are not equal here. So what can I say? I can say that f of x is said to be discontinuous at x is equal to 1. Okay. The 15th question. F of x is equal to 2x if x less than 0. It's equal to 0 if 0 less than or equal to x less than or equal to 1. It's equal to 4x if x greater than 1. So I have written the question again here. Now what are the points you'll have to check for continuity here? At x is equal to 0 and at x is equal to 1. Okay. So first we'll check at x is equal to 0. So when I check at x is equal to 0, what is it you have here? First we'll find out what is the left hand limit. Limit of x tending to 0 minus, it means that for x less than 0, what is your f of x equal to here? 2x. So I have written it as f of x equal to 2x. So what will you get? So here you will have to put x is equal to 0 minus h as h tends to 0. Correct? Now your limit of h tending to 0, f of x is equal to limit of h tending to 0, 2 into your x is replaced by 0 minus h. So you will have it as limit of h tending to 0 minus 2h. Now substitute the value of h here. What will you get? It as equal to 0. Correct? Now the right hand limit. What's the right hand limit you get? Limit of x tending to 0 plus. It means that for x greater than 0. So for x greater than 0, what is your f of x equal to here? F of x is equal to 0. If you see the question here, for x greater than 0, that is this part. Okay, if you see for this part, what is your f of x equal to here? It is equal to 0. That is what I have written it here. So here it is equal to 0 in this case. Now if you see, these both are said to be equal. Are they equal in this case? Actually, yeah, they are said to be equal. Therefore, I can say that LHL is equal to RHL at x is equal to 0. Therefore, f is said to be continuous at x is equal to 0. Got it? Now the next one I'll have to check at x is equal to 1. So at x is equal to 1, you've got the left hand limit. Limit of x tending to 1 minus f of x. So limit of x tending to 1 minus means for x less than 1. So for x less than 1, what is your f of x here? Your f of x is nothing but for x less than 1, your f of x is equal to 0. So how do I write in this case? Your f of x is equal to 0 you get here. Similarly, your right hand limit. What's the right hand limit? For limit of x tending to 1 plus. It means that for x greater than 1. For x greater than 1, so here in this case you see for x greater than 1, what is your f of x equal to here? It is equal to 4x. So how do I write here? It's equal to 4x. So it is x tending to 1 plus means I will write x is equal to 1 plus h as h tends to 0. So you will write it as limit of h tending to 0. F of x is equal to limit of h tending to 0, 4 into 1 plus h. So here when I substitute it, you will have it as 4 into 1 plus 0, which is equal to 4. your left hand limit is not equal to the right hand limit at x is equal to 1, because you have got 4 here and you have got 0 here. So what do I say? They are not equal. Therefore f of x is continuous everywhere except at x is equal to 1. In other words, it is not continuous at x is equal to 1. 17th and 18th question, another 2 important questions you have. Till now, so far the problems whatever I have told you, you checked whether it was said to be continuous or not, okay, at the points there. Actually, where you had the point of discontinuity or continuity. 17th and 18th question are not like that. Here in this case, if you see, the function is said to be continuous at one point. It is given that the function is continuous and you will have to find out the relation between the unknown values. This is what you will have to do under the 17th and the 18th question. So here the 17th one, find the values of a and b. There are 2 unknowns here, a and b, so that the function is said to be defined by f of x is equal to ax plus 1 if x is said to be less than or equal to 3, and it is equal to bx plus 3 if x is said to be greater than 3, okay, and it is said to be continuous at x is equal to 3. See, read the question here. This is the key word for us. It is given that the function is said to be continuous. So you all know that if the function is continuous, left hand limit is equal to the right hand limit. So that part you are clear. So here it's given f of x is continuous at x is equal to 3. Therefore you can write limit of x tending to 3 minus f of x is equal to limit of x tending to 3 plus f of x. So here limit of x tending to 3 minus means, what is it actually here? It is x less than 3. X, this one is nothing but x greater than 3, you know. So for x less than 3, it is equal to ax plus 1. That's what we have here. And you know this x can be replaced by what? 3 plus h as h tends to 0. Sorry, 3 minus h as h tends to 0. So you write it as limit of h tending to 0. A into 3 minus h plus 1. So you have it as 3a minus 3h plus 1. So substituting it, what will you get here? This becomes 0, so you are left with 3a plus 1. Got it? Now your right hand limit. What's your right hand limit here? Limit of x tending to 3 plus f of x is equal to limit of x tending to 3 plus. Very well know for x greater than 3. So for x greater than 3, what is your f of x here? F of x is nothing but equal to bx plus 3 you get here. Okay, it is equal to bx plus 3. So how do I write it here actually here? It is equal to bx plus 3. Now this is equal to limit of h tending to 0. Your x will be replaced by 3 plus h. B into 3 plus h plus 3 you get. Now you multiply it here. What will you get? 3b plus bh plus 3 is what you have here. Substituting the value of h, what will you get? 3b plus 3. Okay. Now what is the condition? We all know it is continuous at x is equal to 3. It means that your left hand limit is equal to the right hand limit. Okay, this is given to us. So your left hand limit is equal to the right hand limit means you know that 3a plus 1 is equal to 3b plus 3. So here if you see 3a is equal to 3b plus 2. So here when you write it, what will you get here? A is equal to 3b divided by 3 plus 2 by 3. Okay, so here this is what you get. So what is it equal to here? It is equal to b plus 2 by 3 here. Okay, so what is it here? The relation between a and b is nothing but a equal to b plus 2 by 3. Okay, another important question. Okay, it's only a 4-mark question here. Okay. The 18th question, okay, another important one here. For what value of lambda is the function f of x equal to lambda into x squared minus 2x if x less than or equal to 0 and 4x plus 1 if x greater than 0 continuous at x is equal to 0? What about the continuity at x is equal to 1? Got it? So it is continuous at x is, there are 2 parts for this question, note it well. First thing, I'll have to find out the value of lambda. What is the condition given? It is said to be continuous at x is equal to 0. This is your first part. What's the second part? I'll have to check for the continuity at x is equal to 1. So here we'll split it as 2 parts. First we'll do till this, then we'll check the continuity at x is equal to 1 here. Got it? So here the solution, what is given to us? Your f of x is continuous at x is equal to 0. It means that your left hand limit is equal to the right hand limit. We all know that. So limit of x tending to 0 minus f of x is equal to limit of x tending to 0 plus f of x. Okay, so here we'll write what is limit of x tending to 0 minus f of x here? It's nothing but for x less than 0. So for x less than 0, what is your f of x equal to? Lambda into x squared minus 2x. How do I write here? It's equal to lambda into x squared minus 2x. Now here you can write it as limit of h tending to 0. Okay, so x will be replaced by what? 0 minus h. So how do I write here? Lambda into 0 minus h the whole squared minus 2 into 0 minus h. You know that this will be nothing but plus h squared. Lambda into h squared minus into minus, you will have it as plus 2h. Now when I substitute it, what will you get? It is equal to 0. Got it? Now, what's the next one here? Limit of x tending to 0 plus. F of x is equal to limit of x tending to 0 plus means it's for x greater than 0. So, for x greater than 0, what is your f of x here? It's equal to 4x plus 1. Got it? Now, what will I write here? 4x plus 1. You can replace your x by 0 plus h as h tends to 0. Got it? So, you have it as limit of h tending to 0, 4 into 0 plus h plus 1, which is equal to limit of h tending to 0, 4h plus 1 you will get here. So when I substitute it, it's equal to 1. So there's a minor problem here. You have this as 0 and this is equal to 1. So here, what can I write here? Your left hand limit is not equal to the right hand limit. So I can say that f of x is not continuous at x is equal to 0 for all values of lambda, because I will not be able to find out lambda here for x is equal to 0. You understood? So your first part is over. Now your second part. What's your second part, children, here? To check the continuity at x is equal to 1. That's your second part. To check the continuity at x is equal to 1, you will have to check the left hand limit and the right hand limit. So, I have just drawn the real line here. You have got 1. Greater than 1, you have 4x plus 1. Lesser than means it will be nothing but also equal to 4x plus 1. What's the reason I say here actually here? So, here we will see what you get in this case actually. You have it as limit of x tending to 1 minus f of x is equal to limit of x tending to. It's nothing but your x less than 1. Okay. So, for x less than 1, I'll just turn the page and I'll just show you here. What have you got? For x less than 0 and x greater than 0 you've got here. So I can only take this function here because it is just 1 here, it is 0. So less than here and greater than here. So I can only take this. Whether it is 1 minus or 1 plus, it's going to be only 4x plus 1. You understood? Okay. So here you have it as x limit of x tending to 1 minus, it's nothing but 4x plus 1. So your x will be replaced by 1 minus h as h tends to 0. 4 into 1 minus h plus 1 here. Limit of h tending to 0, 4 minus 4h plus 1. So it's 5 minus 4h. When you substitute the limit, you will get it to be equal to 5. Got it? Now your right hand limit. What's a right hand limit here? Limit of x tending to 1 plus f of x is equal to limit of x tending to 1 plus 4x plus 1 you will get. So what will happen here? Your x will be replaced by 1 plus h as h tends to 0. So you will have it as limit of h tending to 0, 4 into 1 plus h plus 1, which is equal to limit of h tending to 0, 4 plus 4h plus 1. So what will you get here? Limit of h tending to 0, 5 plus 4h, 5 plus 0 is equal to 5. So are they equal in this case actually here? They are said to be equal. Therefore what can you say here? Your limit of x tending to 1 plus is equal to limit of x tending to 1 minus. Therefore you can conclude that your f of x is said to be continuous at x is equal to 1. You understood, children, here? So it's another very important question here, the 18th one. Okay. How do you find out whether you can find out the value of lambda there? The next one, what did you do? You checked whether it is said to be continuous or not at x is equal to 1.